Hi, and welcome to Meetings in Math. You are here for solving two-step equations and multi-step equations. How can I use inverse steps to solve a two-step equation? So we're moving away from tape diagrams and going towards the algebraic way of solving equations. Today you are going to need your Jaguar Jots where it says 3.5 and using inverse steps to solve equations, a pen and pencil, your perseverance and determination, and a calculator might be nice. So let's start by remembering what inverse operations do. Inverse operations undo the operation so that you isolate the variable. And remember that multiplication undoes division and that addition and subtraction are inverse operations. Also remember that we use that thing called the roads to help us A, organize our work into our nice neat columns, and B, that our roads helps us remember that before you cross the street, you look both ways, and before you that you go any further in your algebraic steps, you do the same thing to both sides. So both ways in the street and both sides of an equation. So before we even start our problem, we are going to put in our road. So going back to our tape diagrams, remember before we can use the variable, we had to get it down to just the variable. So we know that we need to move the 7 before we can mess with the 3x. So you need to write the inverse step on both sides of the equation. Remember the equal sign is the balance point. Both sides of the equation, balance point. So we know that from our tape diagram that we need to move this -7. So if it was subtraction, we are going to add to both sides. So -7 plus 7 is 0. I single line through it. And we are left with 3x on this side equals a 26. This says, right here, x multiplied by 3. So we're going to do the inverse here, but that has to stay exactly the same. So we're not going to change from positive, negative, or negative to positive. So we're going to divide by 3, and we use the fraction bar. So x is going to equal 26 thirds. We are going to leave it just like that. We are not going to change it into a mixed number or a decimal. We're just going to leave it exactly like that. That's it. And we are done with the problem. That's all there is to this. So remember, you have to move the constant away just like we did in our tape diagrams and get it to just the variables. So we should check it by trying it into the original equation. So remember, when you check, you write down what it is you're checking. You write down the original equation and then the substitution. So 3 times 26 thirds minus 7 and 19. This is the other reason it's really nice to write this down. What's 3 divided by 3? 3 divided by 3 is 1. So 26 thirds times 3 is just 26. And 26 minus 7 is 19. This is true. So our problem checks out and we have the right answer. So let's look at our next one. We put in our road, and now we start thinking about variables and constant terms. We know we cannot touch that variable term until the constant term is gone, just like on the tape diagrams. So we need to do the opposite of a positive 8, which is a -8, but we have to do it to both sides. So 8 minus 8 is 0, and we're left with a 4x. And 24 minus 8 is a 16. This is 4 times x, so we'll undo that by dividing by 4. So x is equal to 4, because 16 divided by 4 is 4. So we will check our answer. X equals 4 into 8 plus 4x is equal to 24. So that's going to be 8 plus 4 times 4 equals 24. 4 times 4 is 16. 8 plus 16 is 24. 24 equals 24, so that's true. So we are good. Make sure you box in your answer so that whoever is reading your work knows where your answer is. Because sometimes our answer is going to come in the middle, like it is here, because we had to then check our work and then come back up to our answer. Okay, let's look at number 3. Again, we put in our road. In a two-step equation, there are how many operations to undo? There's 2. That's why it's called a two-step equation. How do you know which inverse operation to use first? Well, it's the one that doesn't have the variable. So it's the term without the variable. So we are going to subtract 8 from both sides. 11 minus 8 is 3, so we have x divided by 2 is equal to 3. So x divided by 2, the opposite is multiplying by 2. The by 2 has to stay the same. It's only the operation that changes. So we are going to multiply both sides by 2, using parentheses to say multiplication. So x is equal to 6. We need to check our work. X equals 6. We put it into the original equation, but we write out the original equation to make sure we have it copied right. So 6 divided by 2 plus 8 equals 11. 6 divided by 2 is 3. 3 plus 8 is 11. So that's true. And so we just practice these problems. The way we get better at algebra problems is to just do a whole bunch of them. And as we do more and more and more of them, they just become more like problems and puzzles to solve rather than hard work to do. So you just want to practice and practice and practice them. So let's go ahead and turn the page. So here we have some more problems. Now that we're getting into positives and negatives, but the rules still hold the same. You just have to use your integer rules to make sure you're doing the problems correctly. So up here, we're going to subtract 8 from both sides so that 4x is equal to a negative 36. It's being multiplied by 4, so we're going to divide by 4. So x is equal to negative 9. I'm going to leave the checking the solution up to you guys. This one right here, you notice I put on all the rows right now. We know we have to move the 6 instead of the 3x. So the opposite of a positive 6 is a negative 6. So now we have a negative 3x and a negative 18. So now we need to divide by a negative 3. So x is a positive 6. And so we just have to be careful about our rules for adding, subtracting, multiplying, and dividing with positives and negative numbers. These last two, go ahead and do them on your own and then come on back. All right, so check your answers. You can see I filled in the checks for you as well. Check those. On the first one, negative 3x plus 7 equals 11. X was equal to 2. On 25x minus 11 equals negative 86. X was equal to negative 3. Okay, so is a number a solution? So we've actually been doing this already. Every time you check it, that's asking that question. Is this a solution? So that's all you had to do. So is it 11 a solution? We're just going to substitute that in. So we're going to put x equals 11 into negative 5 plus 2x equals 17. And that's how we're always going to show it. We're going to put down what we are checking into what equation. And it's mostly to make sure you've copied things down right. Because you can see up here I have a whiteout. That was because I didn't copy something right. So we have negative 5 plus 22 is equal to 17. So negative 5 plus 22, well, that's really subtraction. 22 minus 5, which would be 17. So 17 equals 17. So yes, x equals 11 is a solution to negative 5 plus 2x equals 17. So there you have it. That is algebraic steps for solving two-step and multi-step equations. There you have it. You guys did it. Remember, these take practice, and go ahead and practice them. Even if you're redoing the same exact problems that you already have answers to, practice, practice, practice. Go ahead and redo one or two of the problems that we've already done. And remember, every time you practice, you get a little bit better. Thank you so much for showing up today, and I can't wait to see you in the next lesson. And remember, be kind to each other because we can always use some extra kindness in our lives. And I'll see you next time. Bye for now.